Okay, I hate this question. I think this is the very rare case where a graph question on a reading section is actually kind of hard. And it's hard because the graph is hard. It's hard because it's unclear that the passage is even giving us this information. This is just weird. I do think you can get it by kind of just making some reasonable assumptions and just moving on. But it's hard, and it's hard to explain, and I wouldn't worry about this question. If you got it wrong, don't beat yourself up over it. You're not going to see something like this again. But let's try to piece it together. So based on the passage and the graph, which label on the graph indicates the point at which a salt nanowire breaks? Okay, so let's look at the graphs. We always want to start with the graphs and not the passage because the graphs are usually easier to read, and because the answer could be anywhere in the passage, it might mean a lot of reading and skimming, and it just gets kind of messy. So for the sake of time, try to look at the graph first. So what's going on here? The tip is moving towards the salt surface in the top graph and away from the salt surface in the bottom graph. So why is that important? Well, if we look at the scales here, there's a force. And so presumably if something is breaking, something about the force is going to change. So that leads me to think maybe like Q and T are kind of important points, right? Because something big is happening at that spot. We're going from a force to zero force. So something breaks. So it's probably going to be the case that it's not got any force anymore because it's broken. I don't know. Again, this is a reasonable assumption, but I don't have any proof of that. Here's the one other weird thing about this is the top graph is kind of backwards, right? So if the tip is moving towards the surface and the x-axis is the distance to the surface, the microscope it's moving this way, right? So it's moving from right to left. How can I even show this? From right to left, right? Because if it's moving toward the surface, it's going to start out far away at say 25 nanometers, and it's going to close in and move towards the surface. So that's the problem here, is that's kind of weird. Why the graph is like backwards. On the other one, it's more sensible because now it's moving away from the surface, right? So the distance from the surface is going to increase as it moves away. So that is going out in the opposite direction. So when is the wire going to break? Well, if we remember kind of from the passage, what's happening is they discovered this thing accidentally. They were moving the tip to the surface, and it kind of stretched to get on there. So you might remember this. We had to read a little bit here about this experiment. Here. Moore and his colleagues discovered salt's stretchiness accidentally. They were investigating how water sticks to a surface such as salt and created a super dry salt sample for testing. After cleaving a chunk of salt about the size of a sugar cube with a razor, the scientists guided a microscope that detects force toward the surface. Toward the surface. When the tip was far away, there was no measured force. But within about 7 nanometers, a very strong attraction rapidly developed between the diamond tip of the microscope and the salt. The salt actually stretched out to glom onto the microscope tip. So that's describing this top graph. It's got no force because it's far away, and as it's moving closer, there comes this point Q, where the salt stretches and kind of sucks itself onto the tip. So that's not a breaking point, right? It's actually kind of the opposite, is there's nothing to break. It's not attached, and then as it gets closer, it kind of like attaches itself to it and stretches onto it. And so point Q is that moment where the nanowire is formed, okay? Not where it breaks, where it forms. Now, if we keep reading, we would expect to get the answer that we're looking for. Where does it break? So it keeps talking about the van der Waals forces and blah, blah, blah. Several factors might lead to it. Okay, great. The surface tension is so strong that as the microscope pulls away, the second graph, from the salt stretches. The inside has no choice but to rearrange the atoms rather than break. he says. The bizarre behavior is actually mirrored in the macro world, and then they talk about the nanowires again, and that's it. They never talk about it actually breaking. They say that it stretches instead of breaking. But obviously, if we just think about it, it's going to reach a point where it's going to break. You can't have, a microscope and the salt kind of on opposite sides of a room and still have a really thin wire between them. That just wouldn't make any sense. So here we're making a reasonable assumption that as it moves away, as it moves from left to right on this second graph, it reaches a breaking point where there's no longer any force because the wire has snapped. It stretches for a while. That's what's going on all here. Stretch, stretch, stretch. And then at point T, something changes. It can't stretch anymore. And suddenly the force drops down really fast to zero because presumably the wire breaks and there's no force because it's no longer attached. So that is a very long way of saying that T is the answer. Choice D. So, weird. Normally, I would expect much more solid evidence that that is the answer. The passage does not come out and say it. The graph does not come out and say it. So we are left to kind of make some reasonable assumptions. That's very unusual. Normally, these questions with graphs, we can point to a line. We can point to a spot on the graph. We can say, this is the answer without a doubt. So don't worry too much about this weird exception. But it goes to show that if we can't find the evidence that we're looking for, we can make some reasonable assumptions. And we don't need to know the science here to know that if you stretch something at a certain point, it's going to break. And when it breaks, there's no more force. So we're really kind of, in my opinion, down to a 50-50 shot from the start between Q and T because they look like breaking points. It looks like something major happens at those spots. So that'd be a reasonable assumption. And then it really kind of, in my mind, comes down to understanding that it's going to break when it pulls away, not when it goes towards it. And the passage does back that up. So we're kind of using process elimination. Hope that helped. I hate this question. So if it didn't help, sorry. My heart's not in it. I hate this one. It's poorly written, poorly done. Sometimes it happens. We just do our best and move on. It's okay.